Hello viewers, welcome to this video lecture series on C programming. Today's topic of discussion is on bitwise operators. C language provides 6 operators for bit manipulations. And these operators do not consider the operand as one entity, but instead it operates on individual bits of the operand. So what do you mean by this sentence? Suppose if there is an operand 5, then this is not considered as one entity. Instead, all the bits of this particular operands are considered for operation, that is it operates on the individual bits of the operand. Suppose if you are taking 4 bits to represent this 5, the decimal 5, then your equivalent binary value is what? The equivalent value for this decimal number is 0101. So it takes, the operation is performed on each of these bits. So that is what is the meaning. It operates on the individual bits of the operands, whereas the logical or, logical not and logical or operations, they consider the operand as one entity. Let us see here the bitwise operators. Here in the first column I have written the symbol that is used for the operator. We have the bitwise not. So bitwise not is represented in this manner. We have the left shift and right shift. So left shift operator, this is the right shift operator. We have the bitwise and then we have the bitwise XOR and bitwise OR operator. Bitwise not is a unary operator. It requires only one operand to perform its operation, whereas left shift, right shift, bitwise and bitwise XOR, bitwise OR, all these are the binary operators. They require two operands here to perform the operations. And precedence among the bitwise class is bitwise not is having the level 1 precedence, whereas left shift and right shift, okay, these two are in the level 2. We have the bitwise and level 3, bitwise XOR level 4 and bitwise OR level 5. The bitwise not operator has got the associativity right to left, whereas left shift, right shift, left to right, bitwise and left to right, a bitwise XOR left to right and bitwise OR left to right. So remember, whenever you have an expression consisting of all these operators, you have to give the highest precedence to the not operator, followed by left shift and right shift, then and then XOR and then OR. One important point you need to remember is these operators can be applied on operands of which data type: character, short, int, long. So it can be assigned or unsigned. That means what? It cannot be used on the float or double variables. You cannot perform the bitwise operations, or it cannot be applied to the float or double variables. When we are using the bitwise operations to perform these, so here I have written the truth table also. If the, let us see the truth table for the AND, OR and XOR. That means if the bit of the operand 1 is 0 and the corresponding bit of operand 2 is 0, then the result is what? 0. So here whenever I am writing 0 and 1, that means if the bit of the first operand is 0, and you have to check the corresponding bit of the second operand. So always comparison is done between what? If bit 1 of first operand, you have to compare with bit 1 of second operand only. If it is 15th bit of the first operand, then you have to compare with the 15th bit of the second operand only. Corresponding bits are compared here and the results are mentioned. So if the bit of the first operand is 1 and the corresponding bit of the second operand is 1, then your result is 1 in case of AND. Whereas OR, you can see here 0 0, the result is 0. 0 1 you will get 1, 1 0 you will get 1, 1 1 you will get 1. For XOR, few examples here. First let me give for the bitwise AND. For example, now I am declaring two variables of integer data type. So let me write a equal to 5 and b equal to 3. So for 5, how are you going to write? 0 0. If I am using 8 bits to represent, then this is the value for 5. Then for 3, okay. So now you have, what is this? You are performing the bitwise AND. The bitwise AND operator compares each bit of its first operand. This is the first operand. Compares each bit of its first operand with the corresponding bit of its second operand. If both the bits are ones, the corresponding bit in the result is 1 and the result is 0 otherwise. 0 0 0 0 0 0 0 0 0 1 it is 0, 1 and 0, 0. So the result is 0. Let me take one more example. Integer a equal to bit of the first operand is compared with the corresponding bit of the second operand. If both bits are zeros, the result is 0. Here also 0, 0, 0, 0. Here, so you will get here the result as 0, 0, 0, 0, 0, 0, 0, 1. This, now let me take bitwise a equal to 10. Let me take randomly some numbers. B equal to 11. So what is the result? You are going to perform what? Bitwise, or how will you write? A bitwise operator B. And for the previous example, it is what? A, the bitwise AND operator, and the other operand B. So here the two operands are what? A and B. The values are 10 and 11. Let us write this in binary, because in OR operation, if either of the bit is 1, the result is 1, otherwise 0. Here you can see both the bits are 1, so you will get 1, 0, 1, 1. Symbol is like this, that is the caret symbol. One operand I'll take it as 10, another operand take it as 11. Let us check what is the result. So write it in terms of bits. In case of XOR operation, if both the bits are zeros, then the result is 0. If both the bits are ones, then the result is 0. Otherwise it is 1. So the same XOR operation let us apply here for this example. So what is the logic? If the first bit, or if the bit of the first operand is 0 and the corresponding bit of the second operand is 0, then the result is 0. If the bit of the first operand is 0, the corresponding bit of the second operand is 1, then the result is 1. If the bit of the first operand is 1 and the corresponding bit of the second operand is 0, then the result is 1. If the bit of the first operand is 1 and the corresponding bit is 1, then the result is 0. Apply here for this example, you will get 0, 0, 0, 0. If both the bits are ones, 0 only, 0. Both the bits are ones, 0. Here you can check one bit is 0 and another bit is 1. So this is the result here. Bitwise NOT is a unary operator. It actually produces the ones complement of the given binary value. Suppose for example bitwise of 5. Then in 5 you are writing using the 8 bits. What is the result here? It will give the ones complement. If it is 0, it will be 1. If it is 1, it will be 0. Okay, this is the result of the bitwise NOT operator. If the bit is initially 0, it will be set to 1. If the bit is initially 1, it will be set to 0. This is the operation for the bitwise NOT. Now let us see the shift operators. So shift operators are actually two types. One is the left shift. Left shift symbol, you are going to make use of this lesser than operator two times. Then you have the right shift. What is the syntax here for this shift operator? You have to make use of the operand followed by the operator followed by some number. So suppose if I am writing the operand as A, operator I am using as left shift and the number is 1. So these operators, actually left shift or right shift, these operators shift bits either to the left or to the right. Now what does this number in this particular syntax indicates? This one indicates that the number of places to be shifted. So this one is what? Indicating number of places or positions, you can tell, to be shifted. Let me give an example here. Suppose your value for A is 0, 1, 1, 0, 0, 0, 1, 1. Now you are performing what? A left shift by how many positions you want to get shifted? Left by 1 position. So if you want to shift it by left by 1 position, shift left by 1 place. When you apply this operator, the result will be 1, 1, 0, 0, 0, 1, 1, 0. So what has happened is this one, the operator which was there, the very first number which was here is now shifted to the left. When we apply shift, every bit in A is shifted to the left by 1 position. So finally what will happen? The most significant bit of A is lost. Here this bit is lost. Most significant bit is lost. The LSB is set to 0. LSB is set to 0. So you are shifting means you are shifting by one position means this one has come over here. So this one more position is required, that is set to 0. This is called as the left shift. Suppose let me take one more example. Left shift by 2 positions. Now your A value is how much? A equal to 0 1 1 0 0 0 1 1. So you have to shift left by 2 positions means these 2 bits will get lost here. Your answer will be 1 0 0 0 1 1, and the LSB 2 more bits are required. These 2 bits will be set to 0. So this is the result. We have the right shift operator. So let me give one example for the right shift also. You are making use of these two symbols. A equal to 0 1 1 0 0 0 1 1. Now you want to perform right shift. Let me carry out by one position. So whatever number you are writing here, it shifts by that many position. So here the number is 1. So what will happen to in the right shift operation? When we apply right shift, every bit is shifted to the right by one position. So the LSB, now this time what? LSB is lost, and the MSB is set to 0. LSB is lost, this one. You are shifting it by right. So once you try to shift it by right, your first bit in the result will be this one. Okay, 1. Here you are having 7 bits. So the MSB will be what now? You will be writing it as 0. MSB is set to 0. Suppose if you want to shift by 2 positions, your A value, this is example 1, example 2. A, you want to shift by 2 positions, then these 2 bits will be lost, and your new value will be 0 1 0 0 1 1 0 0 0. Since these 2 bits are lost, the 2 bits in the MSB's position are 0 now. So with this operation, actually what exactly is happening, I'll write a note on it. Shifting once to the left multiplies the number by 2. So finally remember this note I have written here. Shifting once to the left multiplies the number by 2. So if you perform multiple shifts of 1 to the left, it will result in multiplying the number by 2 again and again. Similarly, shifting once to the right divide the number by 2. Hence, if you multiple shifts of 1 to the right will always result in dividing the number by 2 again and again. So that's all in this session. Hope you find this session useful. If you find it useful, please like, share and subscribe to my channel. Thank you. Bye bye and take care.